I'm Alexa.
Colton.
Riley.
So we had section 1, question 1, and it says describe the basics of the banded water snake study and explain the concepts regarding migration and gene flow that are demonstrated. And so the water snake study showed that migration of the snakes is determined by alleles. On the mainland, most of the snakes have bands, but on the islands they do not. This is because the unbanded snakes are because of natural selection. And when the snakes moved from the mainland to the island, the snakes in the mainland brought the allele for the bands.
Yeah, and that band was, it was the dominant allele. And so when they came to the island, it was expected that the migration would cause a homogenizing effect on the population. That dominant allele would seep through, and that there would only be banded snakes on the island. But as Alexa said, the unbanded snakes had been, their population had been maintained by natural selection because they could blend in on the limestone without the bandedness. And so this demonstrated the relationship between natural selection and the gene flow that was happening at that time, because they kind of balanced each other out. The natural selection favored the unbanded snakes, while the migration of the dominant allele kept the banded snakes around, and they balanced each other. So
awesome. Well, I've got question 2. So it says to compare the new, the intermediate, and the old bladder campion populations and describe the basic principle that is demonstrated. So pretty much the old bladder campion is a special flower. So I believe it was on the islands of Sweden that there's a lot of glaciers, and these glaciers are constantly building up due to the cold weather and getting higher. So there's constantly islands being formed. So this flower, there was a special thing that's important to understand. This flower was always one of the first populations of flower that could actually grow on these glaciers before any other plants could get there. So you always get a lot of different populations. So pretty much what was going on is there were different kinds of populations. You had your young populations, your new and young, then you had your intermediate, and then you had your older populations. So the newer populations, they had a lot of variation, and the reason why is because when you have these small populations and the migration effect, you're going to get a lot of variation, and a lot of those different alleles are going to mix up in new combinations until fixation occurs later when there's a larger population, a larger allele frequency of a specific allele. But the intermediate population had a lot less variation because, as we read in the reading, by migration of other plants from the mainland, their actual home, where the plants actually came from, they competed a lot with a lot of different plants that outcompeted them. There was also a lot of diseases that killed this plant. So through migration of these other plants, it kind of caused a homogenizing effect. And what happened is a lot of these flowers started dying, and they started losing their alleles, and only certain survived due to natural selection that was also helping out with that homogenizing effect. And then after all this happened and fixation started occurring, the allele frequencies eventually started balancing out. You got a little bit more variation with the older populations. Not a lot as much as the young, but a little bit more than the intermediate when you lose a lot of those genes through reproduction, natural selection of the fittest, and competition of the new plants that came. That was it.